After adding that to the code, the player should be able to spawn in and walk around. Okay, yeah, that didn't work. Minecraft, the sandbox game where the player is let loose in a procedurally generated world made of cubes. Released back in 2009, it went on to be reasonably successful, selling a mere 238 million copies. Games like Terraria took inspiration and made something similar but in 2 dimensions. So at this point, we have Minecraft in its original 3D version, a 2D version, and someone even made a 4D version somehow. But this got me thinking, there isn't a 2.5D version, but could there be? And that's why I set myself the goal of creating a Minecraft clone, but in 2.5D dimensions. Before getting into the development of the 2.5D Minecraft clone, I should discuss a few things. First, the goals. I want to implement these features for Minecraft: the player, a voxel/cube terrain, block breaking and placing, and infinite world generation, but all in 2.5D. Next, I should discuss what actually a 2.5D game really is. A 2.5D game is a bit ambiguous and doesn't really fit a set definition, but from what I can discern, at its most fundamental, is a game that incorporates both 2D and 3D elements. This could either be a game with a 3D world but 2D assets, like Octopath Traveler, or a game made of 3D assets but only played in the 2D plane, like Super Smash Bros. For the game I'm going to make, I'm going to go with the first one. Okay, now let's boost up the Godot game engine and let's get to work. Like any good game dev project, I started out by creating a moving square. As you can see, the player is represented by a 2D square mesh, but is able to move around in any direction in the 3D world. Okay, let's make the player a little bit more interesting by designing a 2D Steve sprite to replace the square mesh. Here's what it looks like when you put it into the game. Next, let's design an idle and walk animation for the player. In the game, I made it so that the player's sprite would update to reflect the direction in which the player is walking. There needs to be some way for the player to rotate the camera and look around the world. You could have the player manually drag it using the mouse, but I decided to go with buttons that would rotate the camera in 90 degrees either direction. Adding some interpolation to the rotation made them nice and smooth. And with that, we can say that the player movement is done. Next, let's talk about meshes and how Minecraft uses them to generate its blocks and therefore its terrain. The Minecraft world is made up of thousands of blocks or cubes that have been generated by maths to create the infinite and unique terrain you see in the game. But before we can get to generating the terrain, we first need to learn how to generate a cube. Each cube in Minecraft is made up of 6 faces, but how does the computer render this in the game world? Well, by using triangles. You may be wondering why games use triangles instead of other shapes like squares or hexagons. Well, I don't know, but ChatGPT does. Nice. So each square face mesh is actually formed of 2 triangles. But how do you generate these triangles? Well, you do this by placing these points called vertices at the positions of where you want each corner of the triangle to be. Then by connecting these vertices up in a certain order, you can generate the triangle. Now doing this for both triangles, on each of the 6 faces, you can generate a cube. I think it's now time we use this information to generate a cube in the game. Starting off, I added the vertices for the cube. To make them visible in game, I placed a spherical mesh at each location. Next, I connected up 3 of the vertices of the first triangle, which then generated my first mesh. I did the same but for the other triangle on that side of the cube, generating my first cube face. After I repeated this for each of the 5 other cube faces, I was able to produce my first cube. So now that we can generate a cube, we can actually get to the fun bit and start generating some Minecraft-like terrain. But before we can generate some organic looking terrain, we first need to learn about noise and how it's used in this process. In particular, we'll look at gradient noise, one popular type being Perlin noise. Let's not get into the details of how this is generated, as most game engines have a built-in generator anyway. But once we have generated the noise to look something like this, it can be sampled say every 1 unit to produce noise data for each x and y coordinate with a value between 0 and 1. Then by multiplying this data by how much you want the height to vary and rounding to the nearest whole number, you can produce some organic looking terrain height data. You can then take this terrain height data and for each x and y coordinates, create blocks up until you reach these height values, in turn producing your organic looking voxel terrain. Okay, now that we understand how terrain generation works in Minecraft, it's time to implement it in our 2.5D game. After spending some time getting the terrain generation working in game, it produced this result. It looks pretty good, generating somewhat natural looking terrain. However, there are two big problems with the current implementation. First, the shadows. As you can see, it doesn't work with the terrain correctly due to the meshes having no normals. And secondly, each of the cubes generates all the faces even when they are not visible, which will cause massive performance problems when the size of the terrain is increased. To solve the normal problem, like any good programmer worth their weight in semiconductors, why bother spending your time trying to figure something out when there's one line of code that already does it for you? This is what it looks like after adding it in, much better. Now to solve the problem of block faces being rendered when they aren't visible, we can do something very simple, which is to only render a block face if it is directly next to air, meaning that blocks hiding other blocks aren't rendered. This is what it looks like once implemented. Now scaling up this terrain, we get something like this. Pretty good, right? Next we'll need to add textures to each block, which will require the use of something called UVs. In the most basic way, a UV works by mapping a 2D texture to a 3D mesh. In the case of our Minecraft light block, we'll have a sprite sheet of block textures, and for each vertex of a block face, we'll set the UV to be the location of the desired texture on that sprite sheet. Okay, let's take this concept and implement it into the game. After spending some time getting it working, it takes the terrain from looking like this to this. After adding this, I feel like it's really starting to look like Minecraft. Now to allow the player to walk around this terrain, we need to implement collision. Luckily, there is another handy one line of code that can do this for us. After adding that to the code, the player should be able to spawn in and walk around. Okay, yeah, that didn't work. A few changes later, I managed to get the collision actually working. Now the player can walk around and explore. However, the terrain looks a bit boring, so I think to spice it up we should add some trees. To start off, I designed the sprite for the tree, as this is going to be a 2D element to the game. Then I randomly spawned in the trees into the world to give this result. Now this looks decent, but it needs to be improved by making the sprite rotate to always face the camera. After doing that, it gave this result, which I think looks pretty good. So far we've implemented the player and also the terrain generation for the 2.5D Minecraft game. As we're about halfway through, I think it's a good time to call this video for now, but in the next part we'll implement both block placing and breaking and also infinite terrain. If you did enjoy this video, why not give it a like and subscribe to the channel. Thanks for watching, bye.